Continuing with factoring polynomials by grouping. Because we have 4 terms in each of these polynomials, we can essentially divide each half into 2 separate terms and find the greatest common factor of each. When we are asked to factor by grouping, there's a pattern that I want you to take notice of. First, we'll handle the left side here. So I'm just going to draw a line and I'm going to divide it by putting the sign with the third term. I'm going to now factor the greatest common factor out of 8y squared minus 12y, and I'm going to look at the coefficients first. And 4 is the greatest common factor there. Now I'll look at the variables. This has 2 factors of y. This has only 1 factor of y, so my greatest common factor only has 1 factor of y. Now I'm dividing 8y squared by 4y. 8 divided by 4 is 2. Y squared divided by y is just y. Now, negative 12 divided by 4 is negative 3. And y divided by y is just 1, so I don't have to write that. And again, double check this with the distributive property every time. 4 times 2 is 8. Y times y is y squared. 4 times negative 3 is negative 12. Y times 1 is y, so I know I've done this correctly. I'm always going to bring this sign straight down. Whether it's positive or negative, the sign to the left of the third term, the first term in the group on the right, always comes straight down. So now I'm looking at 10y minus 15 and looking for the common factor between 10y and negative 15. Between 10 and 15, I know that 5 is a common factor, so I will factor out a 5. This term has a y in it, and this one does not, so I know that 5 is the greatest common factor there. Now, I'll use my parentheses. 5 goes into 10 2 times, and 5 goes into 10y, y times. Over here, 5 goes into negative 15, negative 3 times. What do you notice about the terms in parentheses? Correct, they are identical. That needs to happen when you're factoring by grouping in order to do this next step. If 4y times something plus 5 times the same thing is what we're trying to re-express, we can bring down the 4y and the positive 5 and show this whole binomial as 4y plus 5 times that same factor that is repeated on both sides. We'll look to do the same thing in this example. So I'm going to divide this polynomial into 2 pairs and factor 1 pair at a time. Looking for the greatest common factor between 15a to the 6th and negative 25a to the 3rd, I'm going to look at the coefficients first, always. Between 15 and negative 25, I have a greatest common factor of 5. Again, if one of the factors is negative, you're going to take out a positive first, unless it occurs on the right side, and this sign's going to come straight down. So now I'll look at my variables. This has 6 factors of a, but this only has 3 factors of a, so a to the 3rd would be the variable piece of my common factor. And now I'll express the rest using parentheses. 15 divided by 5 is 3. A to the 6th divided by a to the 3rd is a to the 3rd. Negative 25 divided by 5 is negative 5. A to the 3rd divided by a to the 3rd is 1, so I don't have to put a variable here. Again, check this using the distributive property. 5 times 3 is 15. A to the 3rd times a to the 3rd is a to the 6th, so I know I've done this piece right. 5 times negative 5 is negative 25. A to the 3rd times nothing is, or times 1, is a to the 3rd, so I know I've distributed properly here. On this side, I'm going to bring this sign straight down, always. And now I'll look for the greatest common factor between 6a to the 3rd and positive 10. Since there's no variable piece to this term, I know that my greatest common factor will not have a variable piece in it. So I'm really just looking at 6 and 10. I'm going to factor 2 out of each of those. And again, I cannot factor out an a because this term has no a in it, so now I'll just start my parentheses. At this point, when you're factoring a 4-term polynomial by grouping, you really should be looking for this factor to repeat itself. We'll take 6 divided by 2, and again, it's really negative 6 divided by negative 2, and that's positive 3, so that has matched up. A to the third divided by 1 is a to the third, so now I have the first term of this common binomial factor matching up. Now we'll take positive 10 divided by negative 2, and that will be negative 5, noting again how I have an identical common factor in the parentheses on both sides. That means I can bring down these other terms, 5a to the third minus 2, and have that as one factor times the common factor of 3a to the third minus 5. We'll do that same process here when we have multiple variables to different powers in the same polynomial. Again, if we're going to factor by grouping, we're going to divide this down the middle to the left of the sign of the third term, so if it's positive or negative, we're going to bring it straight down. Over here, I'm looking at 15 and negative 25, the same numbers that I looked at up here, so they have a common factor of 5. This has 3 factors of x. This only has 2 factors of x, so I know that 2 factors of x must be in my common factor. This has no factors of y at all, even though this has 1 factor of y, so my greatest common factor does not have any factors of y. Now I'm going to divide each of these terms by the greatest common factor. 15 divided by 5 is 3. X to the third divided by x squared is x to the first. Again, x to the 3 minus 2, or x to the first. Negative 25 divided by 5 is negative 5. X squared divided by x squared is just 1, so I don't need to put that. And now I have y divided by 1 is just y, so I do need to have a y in this binomial. Again, I should be looking for this binomial to repeat itself on this side. I'm going to bring this sign straight down. Again, whether it's positive or negative, it's always going to come straight down. Now I'm looking at the greatest common factor between negative 6xy squared and positive 10y to the third. Same numbers as above, negative 6 and positive 10, so I'm going to factor 2 out of there. I have an x to the first here, but there is no x over here, so x is not a part of the common factor that comes out. I have 2 factors of y here and 3 factors of y here, so 2 factors of y come out as my greatest common factor. Now I'll divide each of these terms by the greatest common factor. Negative 6 divided by negative 2 is positive 3, which matches up over here. X divided by 1 is just x, which matches up over here. Y squared divided by y squared is 1, so I don't need to include it over here. Positive 10 divided by negative 2 is negative 5, which matches up over here. Y to the third divided by y to the second is just y. Now I need to check to make sure that both of my binomials in parentheses are identical. Since they are, that means I can bring down the terms outside of them to show this entire expression after I've factored out the greatest common factor from each side as 5x squared minus 2y squared, parentheses 3x minus 5y. With each of these examples here, you could always multiply these 2 binomials together using FOIL, and you will produce the polynomial that you started with at the beginning.